Hey, good evening, everybody. I started making this talk when I was reminded of a probability puzzle that I would like to show you tonight. But bizarrely, I was reminded of this probability puzzle when planning my wedding. So I'm getting married in June. I realised that this whole sort of wedding planning process has been really quite mathematical in a number of different ways, more than just, it's amazing how things add up. And I've also been told that sometimes I talk about the wedding in unnecessary detail. So that is what you're getting tonight, so the maths of my wedding. So the first time that maths was useful to us was when we were inviting people. So we didn't want to have to make separate invitations for people coming to different parts of the day. But we solved that problem by posting to literally everybody that we know this thing. So you... So you just find yourself on the Venn diagram. These people were a little bit upset. But at least it's clear, right? Obviously I'm kidding, right? This is not really what our wedding invitations look like. And actually anyone who was invited to the ceremony was also invited to the reception. So in fact they looked like this. But actually I'm still joking, right? This did not happen. We're getting married in Cornwall, that's actually true. And to get to Cornwall you have to travel quite a long way, both physically and back in time. So we felt it was a bit unfair to invite people all that way just to go through a reception. So in fact everyone is invited to everything, and our wedding invitations looked like this. So if you've ever planned a wedding, there's always one. And so once we'd invited people, we then needed to think about the ceremony, and so having what is called a distinctive ceremony, which we've been told means that we can make it sort of unique to us, with vows that reflect our own personal values and views about marriage. That is, as long as those values are encapsulated in one of these 5 preset vows. So having a look at the vows, we notice there's quite a few things that you can promise each other. So you can promise to love, honour and cherish, or just comfort and cherish, or love and honour makes a comeback down here. And I was annoyed that these combinations of promises don't appear to have been kind of chosen in any sort of systematic way. And they don't cover all the possible combinations. Can be worse. And the second thing that you need to consider is how long you're willing to make these promises for. So you can go for as long as we both shall live, or through the good times and the bad, which is clearly less than 100% of your life together. So it leaves out all those times that are just going to be distinctly average. Or if you want to make promises that cover even less of your time together, you can go for just in the times of specifically joy and sorrow. But what if you want to make these promises over this time frame, or vice versa? So we did what any sensible person would do with 2 variables, and we made a vow chart. This is obviously an example, right? But we have made our own vow chart, which we are just going to reveal at the ceremony. But my fiancé, Dave, who clearly doesn't care about giving things the correct mathematical name, wants us to call it our hers and histogram. So once we thought about the ceremony, we then needed to plan the reception. So we needed to make a seating plan for the meal. So I went online to look for some advice. And one particular wedding website said, oh, it's really tricky because there's so many different ways that you can seat your guests. And it said, in fact, the number of combinations for seating n guests in n seats is n factorial. Right, so we've got 80 guests coming to our wedding. So that is 80 factorial, which, if you work this out, is a mere 7.4 times 10 to the power of 18. Or otherwise known by mathematicians as quite a large number. So our guests are going to be sat around 10 tables of 8. Here is one of them. And so this calculation assumes that this arrangement is different from the arrangement that you get if you rotate everybody one place anti-clockwise. And I feel like we have got enough decisions to be making without having an opinion about what rotation our guests sit in. So I think that all rotations are the same, and there are 8 rotations per table and 10 tables. So I'm going to divide this number by 8 to the power of 10, and we get an ever so slightly smaller number. And the next thing we realised we really didn't care about was where each group physically sat in the room. So we don't care if group 2 and group 1 swap tables here, that's fine. And there are 10 factorial ways of matching up the groups of people with the 10 tables. So I'm going to divide by 10 factorial, and down to 10 to the power of 100. So at this point, I googled number of atoms in the universe. In the hope that this would be somewhere comparable. And it turns out this is just way too huge, right? So the kind of upper bound of the estimate for the number of atoms in the universe is 10 to the power of 82. So to get this down to below that number somehow, the only thing you can really do is say that I don't care at all about how those 8 people sit on that table. So they can sit in any permutation that they like. And so in order to do that, I'm going to divide by 7 factorial to the power of 10. So it's 7 factorial because we've already got the 8 from when we dealt with the rotations. So we are down to, in the order of 10 to the power of 66. It turns out that there are approximately 10 to the power of 67 atoms in our galaxy. Right, so if you want to get the number of seating combinations for your wedding down to the same as the number of atoms in our galaxy, all you've got to do is say, I don't care which group sits on which table or how they sit on those tables. And so once you've got your 10 to the power of 66 groupings, which one is the best? Well, obviously we can't try them all, but some mathematicians have turned this into an optimization problem, which is solved by a computer program. And the first thing you need to do to set up this problem is to give each pair of guests like a compatibility score. So a score of 50 means that this pair are a couple, so you definitely want them to be on the same table. And this score of 0 means this pair of people don't know each other at all. And then effectively you find the sum of all of the scores that are associated with pairs of people who end up on the same table. And the solution is basically the table grouping that maximises that sum, so maximises that total number. And I think this is really, really nice. But this sort of optimisation problem is NP complete, which as far as I understand it means if you're planning a wedding, you probably don't have time for that. So how have you made your seating plan? Once you've made it, you want to kind of make damn sure that people sit in the seat that you have told them to sit in. Like if one person sits in the wrong seat, then chaos ensues. Or does it? How much of a problem is it if one person sits in the wrong seat? And so here enters my probability problem. So, at our wedding, everybody has been told in advance which of the 80 seats is their seat. Let's imagine that the first person who comes into the reception, and that's them, it's in Cornwall, right, has forgotten which is their seat. And they decide that the best way to resolve this situation is to choose their seat randomly, thanks for that. And then person 2 comes in, that's them, it's on a hill. And if their seat is free, they can remember which is their seat. So if it's free, they sit in it. But if it's not free, they are too polite to ask person 1 to move. So they then choose their seat randomly. Right, and this continues. The same thing happens to person 3 and so on all the way up to person 80. If their seat is free, they sit in it. But if it's not free, they choose their seat randomly. And the question is, what's the chance that person 80, and in this case, that's me, gets to sit in their own seat? And when I first saw this, I thought, this is really complicated. There's so many different possible things that can happen. But it turns out the answer is just a half. And to get there, the first step you need to kind of make is to realise that there's only 2 possible seats that person 80 can end up in. And that is seat 1 or seat 80. And if you're not convinced of that, we could do an example. So let's imagine, so person 1 chooses randomly, let's imagine that they choose seat 20. Okay, they're in the wrong seat. And that means that person 2 to 19 are fine, they can just sit in their seats. Then person 20 gets on, and they, it's by the sea, so they see that their seat is taken, and they need to choose randomly. So these are all full, so let's say they choose, I don't know, seat 53, there we go. And then everybody up to 52 is fine, and then person 53 gets on. And so this cycle of displacement continues. Right? They could choose one of these ones, but at some point somebody, and it could be person 79, or it could be somebody earlier on, or it could even be person 1, right at the start, but somebody needs to end this cycle of displacement by either choosing seat 1, which means everyone else can sit in their seat, including person 80, or by choosing seat, by choosing seat 80. Right? Which means that these people are fine, but person 80 is forced to sit in seat 1. And whether person 80 ends up in seat 1 or seat 80 is determined by the decision that the person who ends the cycle of displacement makes. And there is no reason why this person is any more likely to sit in seat 80 over seat 1 or vice versa, so it's a 50% chance each. So the chance that I end up in the right seat at my wedding is 50%. And that concludes my talk. You have all now heard more about my wedding than my fiancé has done in the last 18 months, so thank you very much for listening.